Welcome to Section 16, Class 1 and Class 2 circuits. It is your responsibility to understand and apply all requirements of the Canadian Electrical Code Part 1, including those not addressed in the training. Do you want to know how to take this?
Hi, I'm Olivia, your subject matter professional for this learning. I will help you to understand and be able to apply the requirements of the section of the Canadian Electrical Code Part 1.
The aim of this training is to provide new knowledge and to support the development of new skills that you can apply immediately to your job. The purpose is why you are taking this learning. To directly support the purpose, this learning has identified objectives. Here is what you will learn as you take this training. This training is divided into topics. These topics build on each other, so a best practice is to review them in the order they are presented. Save or print a copy of the Quick Reference Guide. It is located in Resources. Use this quick reference guide to take notes and as a practical job aid for this code section.
The following terminology is used throughout this course. Click each term to read the definition. Cable bundle. 2 or more cables that are tied together or in contact with one another in a closely packed configuration for a length of at least 1 meter. Class 2 power and data communication circuits. Class 2 circuits in which the conductors transmit power, data, or both. A communication circuit is a circuit that is part of a communication system. A control circuit is a circuit that carries the electric signals directing the performance of a control device, but that does not carry the power that the device controls. Powered device. Equipment supplied with power from power sourcing equipment which can communicate data. Power sourcing equipment. Equipment that supplies power to powered devices and which can communicate data. A remote control circuit is any electrical circuit that controls any other circuit through a relay or an equivalent device. A signal circuit is any electrical circuit other than a communication circuit that supplies energy to a device that gives a recognizable signal, such as circuits for doorbells, buzzers, code calling systems, signal lights, and more. The scope covers Class 1 and Class 2 circuits. The requirements set out in Section 16 are based on 2 assumptions. Under normal conditions, voltages not more than 30 volts, extra low voltages, do not constitute a shock hazard great enough to require rules as restrictive as those for voltages greater than 30 volts, and, under normal conditions, power levels not exceeding 100 VA or volt amps do not constitute a fire hazard great enough to require rules as restrictive as those for power levels greater than 100 VA. Section 16 separates circuits into 2 classes, Class 1 or Class 2. Circuits belonging to these 2 classes can be defined as Class 1 and Class 2 remote control circuits, Class 1 and Class 2 signal circuits, Class 1 extra low voltage power, Class 2 low energy power circuits, and Class 2 power and data communication circuits connecting power sourcing equipment and powered devices. An example of a remote control circuit is a microprocessor-based circuit with an output that closes a relay to operate a pump. An example of a signal circuit is a push button that is connected to a doorbell. An example of a power circuit is a solenoid valve used to control the flow of water in a heating system. An example of a communication circuit are the wires running to a telephone. An example of a circuit forming an integral part of a device are the conductors connected to the printed circuit board in a computer. Some communication circuits are power limited and have the characteristics of Class 2 circuits but are not considered as such because they carry data, voice, radio, television, and telegraph signals. As a result, Subrule 2 excludes communication circuits from the application of this section. Subrule 2 also excludes circuits that form an integral part of a device, such as circuits inside computer enclosures, annunciators of paging systems, telephones, intercoms, or process equipment. Class 1 extra low voltage power circuits are circuits that are neither remote control circuits nor signal circuits, but that operate at not more than 30 volts, where the current is not limited in accordance with Rule 16-200, and that are supplied from a transformer or other device restricted in its rated output to 1000 VA, or voltamps, are classified as extra low voltage power circuits and are considered Class 1 circuits. This type of circuit must supply power at not more than 30 volts, which is not considered a shock hazard. And finally, Class 1 extra low voltage power circuit classification is done through power limitation of up to 1000 VA rather than listing a specific maximum current. Class 2 power and data communication circuits shall be in accordance with Rule 16-300 as required by Rule 16-012. Since communication circuits do not pose the same fire and shock hazard as Class 1 circuits operating at their maximums, Class 1 circuits may not share the same cable as communication circuits. This is to protect personnel working on the communication circuit. To avoid confusion during installation and maintenance, Class 2 remote control and signal circuits that share a cable assembly with insulated conductors that form parts of communication circuits are considered as communication circuits. As a result, they must comply with Section 60. In an increasing number of installations, Class 2 circuits contain conductors that supply both power and carry data between equipment. These types of installations must comply with 16-300. At the beginning of this section, it is pointed out that Class 1 circuits have specific power and voltage restrictions. Those voltage restrictions include extra low voltage power circuits that are limited to 30 volts maximum and a maximum power level of 1000 VA. Experience has shown that the 1000 VA limit of the code is a relatively safe power value. Class 1 remote control and signal circuits, by nature of their design and use, do not require much current, typically 5 amperage or less. For that reason, Rule 16-100 2 specifies a voltage limitation of 600 volts, which is a common industry standard. Since Class 1 circuits present a fire and shock hazard, 16-102 indicates the requirements for enclosures, equipment spacing, conductor ampacity, color coding, bonding, grounding, overcurrent protection, etc., applies equally to Class 1 circuits as it does to other types of circuits. However, there are several exceptions which are addressed in Rules 16-104 through 16-118 as well. Class 1 circuits must comply with Section 14 of the Code with regards to overcurrent protection according to Rule 16-104. However, there are several exceptions to this requirement. Subrule 1A indicates that other rules can permit or require overcurrent protection that differs from Section 14. Examples of this include the requirements for transformers and capacitors in Section 16, the requirements for motors in Section 28, and the requirements for heaters in Section 62. Subrule 1B indicates that number 18 American wire gauge, AWG, and number 16 AWG conductors are permitted for Class 1 circuits, but are limited to a maximum overcurrent device of 5 amps and 10 amps respectively. Lastly, Subrule 2 addresses circuits supplied by a transformer. If the overcurrent protection is installed at the secondary terminals and the transformer is suitably enclosed, additional overcurrent protection is not required on the primary. The branch circuit overcurrent protection for the circuit supplying the transformer is still required. Copper conductors must not be smaller than number 14 AWG. However, Rule 16-110 permits the use of copper conductors smaller than number 14 AWG for Class 1 circuits if they are installed in a raceway, installed in a cable assembly, within a flexible cord in accordance with Rule 12-402. Since these smaller conductors are not as strong as larger gauge conductors, limitations are placed on the installation method of the smaller conductors. Conductors may not be smaller than number 16 AWG for individual conductors pulled in raceways, number 18 AWG for individual conductors laid in raceways, and number 18 AWG for an integral assembly of 2 or more conductors. Different Class 1 circuits are permitted to occupy the same enclosure, cable, or raceway if all conductors are insulated for the maximum voltage of any conductor in the enclosure, cable, or raceway. Unless they're connected to the same equipment, insulated power circuits and insulated conductors of a Class 1 circuit are not permitted in the same enclosure, cable, or raceway. Circuits that are neither remote control circuits nor signal circuits, but in which the current is limited in accordance with Rule 16-200, are classed as low-energy power circuits and considered to be Class 2 circuits. It is important for you to know that there are limitations to Class 2 circuits. Depending upon the F open circuit voltage, Class 2 circuits are limited as follows. Select to learn more. A. Circuits in which the open circuit voltage, OCV, does not exceed 20 volts shall have overcurrent protection rated at not more than 5 amperes, except that overcurrent protection shall not be required if the current is supplied from 1. Primary batteries that under short circuit will not supply a current exceeding 7.5 amperes after 1 minute. 2. A transformer or other power supply device having a Class 2 output. Or 3. A device having characteristics that, under normal operating conditions or under fault conditions, limits the output current to a value not exceeding 5 amperage and the output power to a value not exceeding 5 amperes multiplied by OCV in VA. B. Class 2 circuits in which the open circuit voltage, OCV, exceeds 20 volts but does not exceed 30 volts shall have an overcurrent protection rating not exceeding 100 VA divided by OCV amperes, except that the protection is not required when the current is supplied from 1. Primary batteries that under short circuit will not supply current exceeding 5 amperes after 1 minute. 2. A transformer or other power supply device having a Class 2 output. Or 3. A device having characteristics that, under normal operating conditions or under fault conditions, limits the output current to a value not exceeding 100 VA divided by OCV amperes. C. Circuits in which the open circuit voltage, OCV, exceeds 30 volts but does not exceed 60 shall have an overcurrent protection rating not exceeding 100 VA divided by OCV amperes, except that the protection is not required when the current is supplied from 1. A transformer or other power supply device having a Class 2 output. Or 2. A device having characteristics that under normal operating conditions or under fault conditions limits the output current to a value not exceeding 100 VA divided by OCV amperes. D. Circuits in which the open circuit voltage, OCV, exceeds 60 volts but does not exceed 150 volts shall have an overcurrent protection rating not exceeding 100 VA divided by OCV amperes, and in addition shall be equipped with current limiting means other than overcurrent protection that shall either under normal operating conditions or under fault conditions limit the output current to a value not exceeding 100 VA OCV amperes. Additionally, a device having energy-limiting characteristics shall be permitted to consist of a series resistor of suitable rating or another similar device. A Class 2 power supply shall not be connected in series or parallel with another Class 2 power source. And a device having a Class 2 output shall be permitted for use as a device having energy-limiting characteristics if it is marked as being suitable for the purpose. Essentially, a circuit can be a Class 2 circuit if the voltage is 150 volts or less and the maximum power of the circuit supply is 100 VA. In Class 2 circuits, the insulated conductors and equipment on the supply side of overcurrent protection, transformers, or devices having Class 2 outputs shall be installed based on the requirements of other appropriate sections of this code. In the picture on the screen, you can see a Class 2 doorbell transformer mounted to a junction box. Inside the junction box are the 120-volt supply conductors. This wiring must comply with all relevant sections of the code. For example, Section 4 for wire size, Section 10 for grounding and bonding, and Section 12 for wiring methods, etc. The exposed wiring on the transformer is connected to the Class 2 output and must meet the requirements of 16-200 to 16-226. Transformers or other devices having Class 2 outputs must be protected on the supply side by an overcurrent device with a rating or setting not exceeding 20 amps. A Class 2 power supply unit must have permanent markings that are visible after installation that indicate the class of supply, its electrical rating, and suitability for wet locations when intended for wet locations. Overcurrent protection must be provided as required for any other circuit. This protection shall not be of an interchangeable type, be permitted to be an integral part of a transformer or other power supply device, and be located at the point where the conductor to be protected receives its supply. The requirements for Class 2 conductors are outlined in Rule 16-210. The conditions of use and insulation designation for Class 2 conductors are shown in Tables 11 and 19. Click each link to display each table. Copper conductors smaller than number 14 AWG are permitted for Class 2 circuits. Because of their smaller size, they are less robust than larger conductors and more susceptible to damage during installation. As a result, there are special requirements regarding the installation of these smaller conductors. The conductors must not be smaller than number 16 AWG for individual conductors pulled into raceways, number 19 AWG for individual conductors laid in raceways, number 19 AWG for an integral assembly of 2 or more conductors, number 22 AWG for an integral assembly of 4 or more conductors, number 24 AWG for an integral assembly of 6 or more conductors, and number 26 AWG for an integral assembly of 10 or more conductors. Type ELC cables shall not be pulled into raceways. For Class 2 circuits, the maximum ampacity permitted for conductors number 16 AWG or smaller is specified in Table 57. Additional considerations include when cables or raceways exceed 3 conductors, the derating factors below the ampacity table must be followed. When cables or raceways are installed in ambient temperatures above 30 degrees Celsius, the derating factors from Table 5A must be followed as per the note below the table. Ampacities for 8-conductor cables used for Class 2 power and data communication circuits are specified in Table 60. Since the requirements for the wiring methods for Class 2 circuits are less rigorous than for other circuit types, separation from other wiring systems is crucial to prevent an unintended transfer of energy into the Class 2 circuit. As a result, Class 2 circuits must be separated at least 50 millimeters from insulated conductors of electric lighting, power, or Class 1 circuits operating at 300 volts or less, and 600 millimeters from any insulated conductors of electric lighting, power, or Class 1 circuits operating at more than 300 volts. For the same reasons, Class 2 circuit conductors must not share the same raceway, compartment, outlet box, junction box, or similar fitting with conductors from power, lighting, or Class 1 circuits, unless separated by an acceptable barrier, or as permitted by Subrule 4. Subrule 5 permits electric lighting, power, and Class 1 circuits to occupy the same cable as Class 2 circuit conductors under the following conditions. The cable is marked as suitable for this application. The Class 2 conductors in the cable are used to supply and/or control remote devices that are associated with the other conductors of the cable. The conductors are insulated for the maximum voltage of any conductor in the cable. Class 2 installations will often use the general wiring methods found in Section 12. In addition, Section 16 provides extra requirements for Class 1 and 2 circuits. Examples are Doorbell circuits, signal circuit that uses wiring method from the Class 2 transformer to the doorbell and push button would come from Section 16. The extra low voltage cabling for a gas valve, including the wiring to the thermostat, are safety control devices. Therefore, they must conform to the Class 1 wiring methods. The extra low cables for controlling a central vacuum system conforms to a Class 2 wiring method. Equipment located on the load side of overcurrent protection, transformers, or devices having Class 2 outputs shall, for Class 2 circuits operating at not more than 42.4 volts peak, be acceptable for the application, and, for Class 2 circuits operating at more than 42.4 volts peak, comply with Rule 2-024-1, Use of Approved Equipment. Lighting products, electromedical equipment, equipment for hazardous locations, and thermostats incorporating heat anticipators must also comply with Rule 2-204-1 with regards to use of approved equipment. The operating voltage of the equipment referred to in Sub-Rule 1 shall be suitable for dry or damp locations, for wet locations, immersion not included. Rules 16-300 to 16-350 apply to Class 2 power and data communication circuits. The conductors of these circuits transmit power, data, or both. In essence, devices are powered and transmit data down the same conductors simultaneously. Examples of these types of circuits include extra low voltage lighting systems, closed circuit television systems, CCTV, wireless access points, WAP, distributed antenna systems, DAS, and building automation systems, BAS. Similar to other types of Class 2 circuits, fire and shock hazards are minimized in Class 2 power and data communication circuits by placing limitations on the power and voltage employed by the circuit. Circuits cannot exceed 100 VA voltamps, 60 VDC volts direct current.
This scenario is an opportunity to apply what you've just learned. Click Enter Answers to get started.
Conductors for Class 2 power and data communications circuits must be suitable for the application, in accordance with Rule 12-102 Sub-Rule 3. The ampacity of a conductor used in a Class 2 power and data communication circuit is determined by whether the conductor is marked with an ampacity and the suffix LP or not. Where communication cable marked with the suffix LP for limited power is used, A. The maximum current that each insulated conductor is permitted to carry shall be limited to the current rating marked on the cable. Where communication cable not marked with the suffix LP is used again, A. The maximum current that each insulated conductor is permitted to carry shall be as specified in Table 60, based on 1. The size of the conductor, 2. The cable temperature rating, 3. The number of cables in a cable bundle in contact with each other, and 4. The smallest conductor size and lowest temperature rating of any cable in the cable bundle. Click each number to see additional factors affecting the ampacity and installation of Class 2 power and data communication conductors. The maximum current permitted in a Class 2 power and data communication circuit shall not exceed the rating of the connectors, such as modular plugs or jacks, or components used in the circuit. The correction factors of Table 5A shall apply where Class 2 power and data communication circuit cables are installed in an ambient temperature exceeding 30 degrees Celsius. The circuit length shall ensure that the voltage at the point of utilization is within the rating or voltage tolerance of the connected power device or devices. Where more than one cable bundle is installed in a ventilated and ladder-type cable tray, cable bundles shall be spaced at not less than 25 millimeters. Notwithstanding Sub-Rules 2 and 3, cables for Class 2 power and data communication circuits shall not be required to comply with the cable bundling requirements where the rating of each output circuit supplied by power sourcing equipment cannot exceed 0.3 amps to any load conductor, and the cables have a minimum conductor size of number 24 AWG. Where the maximum conductor termination temperature for equipment is not marked, the maximum conductor termination temperature shall be 60 degrees Celsius. It is important to know the correct wiring method requirements for conductors for Class 2 power and data communication circuits. Rule 16-340 explains those requirements. Shall only be used when they are part of a common cable assembly marked as being suitable for the application. Extending beyond a building shall be installed in accordance with Rule 16-224 on circuits extending beyond a building. Shall comply with Rule 12-012 on underground installations. Shall not be connected in series or parallel with other conductors for Class 2 power and data communication circuits. All Class 2 power and data communication circuits must be permanently marked and visible for inspection after installation. These markings must indicate class of supply, electrical rating of power sourcing equipment.
You covered a lot in this course. This summary helps you to recall the main concepts and requirements of this code section. You have now completed the learning on the main concepts and requirements of this code section. Next, you will take the open book quiz through the link on